Hi everyone. Have you ever had this issue where when you were making a game, sometimes your player is obstructed by an object and your camera just doesn't see the player anymore? A good example of this is this simple scene in Unity I've just created, where if the player hides behind a wall, you can't see him anymore. That can become an issue if you're fighting enemies and you kind of lose track of where the player is. So the result of the tutorial will basically be that if the player is behind the wall, it will become transparent, and it will keep the shadows that the walls are projecting, and this would work on any walls with a certain shader on it, certain material on it. So once you've done all the setup and everything, and you're ready to go, make sure you've got the scene something looking a little bit like this, where there's walls and a player, of course. By now, you should probably have a player that is able to move. Second thing is you want to add a camera, and that camera can be in any angle, because in any case, whatever will be blocking the camera's view to the player will be considered an obstruction, right? And after this, you will have to add a script. So to do so, you will create an anti-object, call it Obstruction, and make sure it's the child of the camera. In that case, you will also change its coordinates to the same position as the camera. And outside or inside of the player, as another empty object, you will say wall check. Or you could call it, what's a better name for it? Player's head. And what it will do, basically, this thing, is you will have to move it up above the player's head, or just on top of the player's head, so that the camera, or more so the obstruction object, will shoot a ray between this object and the player's head, and whatever crosses its path will become transparent. So here on the obstruction object, I'll add a script, and the script could be named anything really, but I'll call it Obstruction Controller. I'll put it in my script folder, and I'll let Unity do its little thing. And when you edit the script, you want to make sure that you add a transform, so a transform point, for the player's head. Well, I mean, it has to be public, so public transform, and transform head. Okay. So second thing you're gonna add to this thing, to the script, to be more specific here, is basically a mesh renderer. So a public mesh renderer that will basically be the. Sorry about the alarms. There's like a lot of crimes in Paris here. Anyways, so yeah, public mesh renderer. And with that mesh renderer, basically, you're gonna call it the obstruction, because the game object itself is not really needed. You don't need to know all the information about the game object that is the obstruction. All you need to know is its mesh renderer, which is what's being rendered. Second thing you're gonna do is basically create a function that you will call private void camera transparent, maybe? I don't know, whatever. Doesn't matter. As long as you have a name. And then with that function, you're going to call it in the update function. And inside of it, you're going to draw a debug line, just to start with, just to see a result, basically. And that line is basically going, as I explained earlier, is going to go from the transform, transform of the current game object that the script is on, so position, and then to the transform head, which was the player's head. And then you can add a color if you want. I don't know what color you're into, but I like green. So let's put, oh wait, I forgot position. Position for for this. Yep, and that's it for now. We'll just try and see the results, see what was being drawn. I'll stay out of game view and more into scene view. You can always, I think, well, I mean, there's no point in, you know, enabling gizmos in game mode, but because like the camera's literally aiming the line. So it's better to see it in the scene view. But yeah, let's see. So as you can see, there's a green line being drawn from the camera to the player's head, and hopefully whatever gets in between that line will be transparent. So you'll have to create a raycast. I'd suggest you create it outside. So what a raycast is just, oops. Wait, first of all, make it private maybe. Is it private? Raycast with a big C. Yes. What am I doing? Oh, I got something wrong. Right, sorry, my bad. So it's raycast hit with a capital H and name it hit. Doesn't really matter what you name it. And within this function, you're going to create a if statement that will basically check whether that line that you have, you know, created here has hit something, and it will bring it out a hit. What am I getting wrong here? What am I getting wrong? Right, because I haven't actually. Okay, my bad. So basically, there's a physics thing that does exactly like what the draw line, what the debug line does, but it actually, you know, does it for detection purposes, for detecting if something has been hit or not. And this is how the function works. So it's line cast, and then brackets, and I do not know why. Oh yeah, and it will basically return a true or a false value. Well, it will return a true and a false value, I think. But the most important part is what comes out of the hit, so you can detect, you know, what has been hit. So first of all, we'll start with a little like debug, just to see what has been hit, and you'll see that if you type hit, then dot, you can basically gather information about whatever has been hit, and usually I would say the best thing to do, I mean, you can get the rigid body, but you could also get the collider of the object you've hit, and if you want more specific, you can just say name, and then you'll get the name of whatever object has been hit by that line. So before actually starting the thing, I would suggest that you would maybe tag, actually no, I mean, maybe remember the names, you know, the names of the objects that are obstructing the player. And then once you've started, you will basically, if I move the player, I'll make sure the line crosses, you know, the camera and the player, and whatever crosses between it will be the wall, for example. And you'll see here, it says wall. Of course, it also detected that whatever it hit was also the model, because technically, I mean, I didn't check too well, but it hit the player's head by a tiny shot. But if I move the player to the, if I can get it to move, I don't know. Yeah. So if I move it to the other wall, for example, why is it so slow? Okay. It will detect wall 2. So to make sure that whatever you hit is a wall and not anything else, you will have to use tags. And these tags you will create by, for example, for the walls, here in the scene. I can move this up. I don't know why the setup is like that, I don't really like it. Anyways, so the walls will basically be tagged, well, you'll add a tag, and you'll call it wall maybe, or whatever, obstruction. Because it's not necessarily always a wall. And you'll save it. And you'll make sure that all the walls, all the obstructions will be called like that. There you go. And inside the code, so inside of this if statement, you will add another if statement, and that if statement will check whether the object that's being hit is a wall, or an object that has a tag wall, basically. So to make sure that it is a wall, you'll basically use what you've used here, just the start of it. And then you'll see another thing called compare tag, which is a function that Unity comes with. And that will basically see whether the tag that, the object has that specific tag of the obstruction. Make sure that when you're spelling it absolutely right. Because if it's not right, then it will never find the correct tag. And once you save it, and you press play, I will show you that, obstruction is not defined. Well, I misspelled it. What a great example. See, it doesn't actually detect it. So let me just fix that error real quick. Obstruction. What did I miss? Oh yeah, because it has an S at the end. So obstructions. Okay. Now it will basically work. Because yeah. All right. So if I move the player, I don't know why I can't get it to move. Hello. Oh wait. God damn it! What's wrong with me? Okay. So I actually press play, and then if you actually go to the wall, you'll see it detects the wall, but it hasn't detected, the other objects that are non-obstructions. So if I go to the other wall, it's also a wall. My player controller is something I just made in, 2 seconds, so it's really bad. Worst case scenario, I'll just move the player itself. Well, not the model, the player. If I can. I cannot. Well, I can do it here. But yeah, so if you move the player and you see, wait, no. Yeah. So let's say extended the map, or I removed this object. It'll give me an error, because basically whatever was being hit isn't there anymore. So now that we've managed to detect the obstructions, what we'll do is we'll take the mesh renderer component that we created up here. Actually, I think I'll rename this to mesh, so that it's not as confusing. Because what we'll be getting from that, we'll be setting this equal to, is the component, and this only the component, not the actual whole game object, but the component that's attached to it, that is the mesh renderer. And we will basically disable it so that it turns transparent. But the rest of the components, like the collider, will stay there, so the player, when it hits the collider, it will basically not fall off the map. Then you can turn it back to true if the ray has stopped hitting that object. So let's see what happens when we play this in Unity. Alright, everything should be good. So if I move the player's position, first of all, you'll see that there's an error, and that error is basically, there's no mesh, there's nothing being hit currently. So what I suggest you do is you actually just take the object that you've created here for the player. I think I might have mistakenly moved the model and not the player. But anyways, so in this obstruction mesh, you want to put the player's head as a default thing when the game starts. But then when you actually move the character and you bring it to the wall disappears and it comes back. Disappears, comes back, disappears, comes back. But in my personal opinion, this isn't really like the best thing you can do, because when you'll realize that when you remove the mesh renderer, the shadows are removed as well, and second of all, it really doesn't look that realistic, and the game feels just not right. It feels wrong. So that's the second step of this tutorial, is to create a shader that will basically keep the shadows, but make the wall transparent. So I know this may seem daunting, but when you create shaders in Unity, they give you the right set of tools, and I actually find it quite easy to do so. So it shouldn't be something too difficult. It could be very unusual, because it's not really something that a lot of people do. But basically, you go to Create, URP, and then make sure it's a lit shader graph. That way you'll name it, I don't know, opacity or something. There you go. Name it opacity. and you'll open it, and it will open this sort of a tree tool where you can add different variables that can change the way the texture displays, and of course the different tiles that will affect the end results. You'll realize that you get, you know, the vertex shader and the fragment shader. All you'll be messing with is the fragment shader, because you don't really mess with the vertices or anything. You're not changing anything, but you'll realize that there's a bunch of different things here. You can do with them as you wish, but really for the basics, all you're gonna use are the base color, and make sure in the graph inspector that it is opaque. It's not, sorry, that it's not opaque, but it's transparent. And then you'll see we'll add the alpha, and that's the value that basically decides the opacity of the object. So to start with, let's add some variables. We'll add a color. We will add a vector 2 for the tiling. We'll add a other vector 2 for the offset. We'll add a actual texture. And then we'll add a simple float for the opacity. Alright, so these are the variables you'll be needing for this shader graph. So let's create the first node, and that'll be tiling and offset. And to link, you'll basically put the tiling here. Make sure this is 1, 1, so that you actually see something. And the offset can stay 0, 0, and you'll link it right here. Second thing you'll need to do is add a sample texture. So the sample texture node. Texture node will be right here, and on this you'll just have to link that, and sorry, the color comes later, but yeah, that's about it. You will also need to add, of course, the texture. Right now there's no texture, but later on you could pick a texture. I mean, it doesn't matter. But yeah, if your wall has a texture, then you have the possibility of adding it. So then you'll create another node, and you'll multiply the color with the sample 2D, and you'll add all of this to the base color. Oops. Get this here. And of course, so now you have a base color, which is completely separate to the alpha, that you can manually raise or decrease as you wish. And so now you have your own proper texture. Alright, so now comes the time where you have to create a new material. And to do so, you'll just go to create material, and let's call it wall. Make sure that this material is not the universal pipeline material, but it's rather a shader graph, and you'll see your own shader graph right here. And here are all the settings you've basically created throughout your shader graph. So you can change the color, the tiling, the offset, the texture, and of course the opacity. Coming back on that, actually, on the opacity, if you would like a better, inspector, you could also make sure that your opacity is not a default but a slider, and you put a range from the minimum, that'll be 0, and the maximum will be 1, and set it to default as 1. And yeah, so this is another shader I created on the side. So it's not called opacity, it is called opacity manager. There you go. So now you have a slider. We'll just make it a little bit better, easier to see. So make sure that you apply that new material to the walls, as well as the obstruction tag. That material by default, I mean, you can see how it affects it. And then through the code, let's get to the scripting. In the scripting, instead of turning the mesh render on and off, what you'll do is bring out the material that belongs to that obstruction mesh, and make it so that you can set a float, which you created, underscore opacity and set it equal to 0.5 because you don't want it to be visible. I mean, you want it to be half visible. And with this simple line of code, it should bring it transparent. And then, of course, you want to set it back to how it was originally, which was completely opaque. Normally with this code, it should work. Also, make sure that it is underscore whatever the name you've given that variable, because that's how it is. You can change it again in here in the shader graph. For example, opacity, you could make it whatever you want here. Make sure it's a reference, not the name, but the reference. Anyways, let's see how it goes. So you can see the ray. Let's see what happens when the player crosses the wall. And it turns semi-transparent. If you see this in action, so the player is behind the wall, you can still see him. Now he's in front of it, behind, in front. And it works with the other wall as well. Behind it, in front of it, behind it. And yeah, there you go. So this is great when you're creating these sorts of games where you might have obstructions between the camera and the player. Of course, if you want to change the amount of obstruction, you could also create a variable inside here and make it a public variable and edit it here as a float. And then you could just decide how much more you want it to fade. Yeah, that's about it. I hope you enjoyed this really long tutorial. I will probably split it into 2 parts because it was a long video. But yeah, see you.